Hold on, does x to the power of 12 minus I to the power of 4 equal x to the power of 6 minus y squared all squared? Let's check. Substitute 6 for x to the power of 6 and 5 for y squared. The left side is 36 minus 25, giving 11. But the right side is 6 minus 5 squared, which is 1. 11 equals 1? That makes no sense. Look at this and check if this is correct. Here's the correct way to factor this expression. We must rewrite x to the power of 12 minus I to the power of 4 using a brilliant hidden rule of algebra. This rule is known as the difference of squares. It states that when you have one squared term minus another squared term, you can easily break it down into two separate factors. This is exactly what makes solving seemingly impossible algebraic equations look completely beautiful and shockingly simple when you know the secret. Look closely at these two powers of 2. They confirm this is a true difference of squares. Now we can finally separate it into two perfect factors. We get x to the power of 6 minus y squared, multiplied by x to the power of 6 plus y squared. The entire initial expression collapses beautifully into these final two pieces. But wait, we are not completely finished yet. Look closely at the first factor, x to the power of 6 minus y squared. You will notice something incredible. We can apply the exact same difference of squares rule one more time. Rewrite x to the power of 6 as x cubed, all squared. Now this piece collapses even further into x cubed minus y, multiplied by x cubed plus y. When we bring down the final piece, x to the power of 6 plus y squared, we get our ultimate answer. The entire initial expression is now perfectly broken down into three separate components. This is the absolute final, most advanced way to solve this New York Regents exam problem. Most students stop at the very first step, but now you know the exact secret to getting full credit. If this ultimate algebra breakdown blew your mind, please like, comment, and subscribe right now for more genius math hacks.